Hello again, HDExaminers. This is Jeff Morrow from Sierra Analytics with another featured feature for HDExaminer. Today's featured feature is Bimodal Distributions. This feature is new in HDExaminer 3.0. If you'd like to see other features that are new in HDExaminer 3.0, check out our YouTube channel, or if you're watching this on YouTube, there's a link in the description below. So, as you probably already know, it is possible for a peptide to have two different duration distributions rather than just one. This is called a bimodal distribution, and here's an example of one up on my screen right now. So when you're calculating these bimodal distributions, what you actually want is to track those distributions separately and see how they move or change or eventually merge over your time course. So the new version of HDExaminer can do just that. So let's zoom in here because this is rather illustrative. So as with any HDExaminer result, the red trace is the actual mass spec data that you acquired. The blue trace is the theoretical isotope cluster that HDExaminer calculates to match your actual data as closely as possible. But in the case of bimodal distributions, that blue trace, the theoretical isotope cluster, is actually the sum of two separate distributions represented here by this yellow trace and this green trace. So if we zoom out, we can see that the yellow trace is this left distribution, and the green trace is this one on the right. And when you sum both of them together, you get the blue trace, which is calculated to match the red trace as closely as possible. So to tell HDExaminer to calculate bimodal distributions, there's several options you should use under Tools Options. So right here under bimodal distributions, you can tell HDExaminer to either try a bimodal distribution only when you, the user, specifically tell it to for a result, or whenever the unimodal result is less than a certain score. So by default, it's set to only when user forces, and I'll talk about how to force it in a moment. But this setting for whenever the unimodal score is less than a certain score, that simply means that if the unimodal fit isn't very good, it will try a bimodal and see if it improves it. Also here under Tools Options, in the deuteration table, there are a whole bunch of checkboxes that correspond to bimodal results. So if you know you're not using bimodal results, you can turn off some of these bimodal things, but in our case, we want all of them. So it's the anything marked with a 2 and anything that says bimodal are the ones you want to be turning on. So what do those look like? Well, for this particular result, if we scroll through, we can see that now instead of just an experimental centroid, we have two experimental centroids. 787.4 is the centroid of this left distribution, which is right about here. And 790.1 is the centroid for the right distribution, which is right about here or so. So those are now tracked separately in HDExaminer. This left-right ratio and the left-right percentages actually tell you the same thing in two different ways. What this is, the left-right ratio is the ratio, the total intensity ratio of the left to the right. So in this case, the left one is bigger than the right one. And in fact, it's about 3.679 times bigger than it. So the ratio is one way to express that. The other way to express it is with these left-right percentages, 78.6% and 21.37. And those, if you do the math, those are actually telling you the exact same thing, just in two different ways. Similarly, the theoretical centroid has two values, again, right about here and right about here. And then the theoretical has the left-right ratio and the left-right percentages. And then finally down here, once we have these two separate centroids, we can calculate the number of deuterium and the percentage of deuterium for each of these. So our first distribution in this case has about 2.3 deuterons on average on it, and the second, the rightmost distribution has about 7.787 deuterons on average on it. So all of that stuff appears here in the results table. You can also see that HDExaminer can find bimodal distributions that are pretty subtle. So if you look at this one, the red trace is actually it's almost a monomodal distribution. It's just kind of a little bit wide and a little bit funny shaped. But in this case, the software did in fact figure out that there are two distributions in there, one right around like this and one kind of like this. And again, their centroids and ratios are reported here in the analysis view. Now, let's suppose that I had a result that like this, that I decided, you know what, that maybe actually is a unimodal. Now, in this case, it's not. But if I decided that I wanted it to be unimodal, I could right-click on the result and select Force Unimodal. And for a unimodal distribution, I can select the same thing instead says Force Bimodal. This is what I was talking about earlier when I was going in the options. You can always tell HDExaminer, no, I don't want this to be bimodal, I want it to be unimodal, and vice versa. And if you have your settings set to only use bimodal when forced, then it will still calculate everything in a unimodal fashion unless you go into individual results and say, no, this one is bimodal, try bimodal. So however you want to do it is fine. If you want to use a score cutoff, then HDExaminer will do that and will try bimodals whenever appropriate. If instead you want to have manual control over that, you can. And you can tell the software to only try a bimodal if I specifically tell you to do so. So one thing you may want to do is also look at bimodal uptake plots. And this is what one of those looks like. It's an uptake plot kind of like you might have seen in the literature, where it's actually two uptake plots that sometimes converge. So in this case, what we have is that our first, third, and fourth time points, our result is actually unimodal, and so it's the same for both modes. But this second time point has a bimodal distribution. We can see here that the two distributions are centered around 1 deuterium and around 3 deuterium. And we can also see from this gray circle that the left distribution, the lower one, is bigger than the right distribution. And so that is what a bimodal uptake plot looks like. Now, what about the protein level plots? What about the heat map? How do you show, for example, a bimodal heat map? Well, the short answer is you don't. So for protein level views, such as the heat map that we can see here, there's this toggle button in the upper right. So anytime your project contains bimodal results, then you will see this button in the upper right-hand corner of the window. This is a toggle switch. This means when the left peak here is selected, that means we're looking at the left distributions for every bimodal result. And if we click it, it toggles to the other one, and now we're looking at the right distributions for every bimodal result. So for the in the analysis view and the uptake plot, we can see both distributions at once. But once you get to the protein level, unfortunately, there's no good way to do that anymore. And so for protein level views, such as the heat map and the butterfly plot and the volcano plot, you have to use this toggle switch to tell HDExaminer whether you want to be looking at left or right distributions. And in fact, if we toggle this, we can see that the heat map is bluer for the left distributions and a little bit greener and redder for the right distributions. And that makes sense because the left distribution is the one that's less deuterated and the right distribution is the one that's more deuterated. And so that is a tour of bimodal distributions. Once again, this feature is new in HDExaminer 3.0. If you have any questions about HDExaminer 3, or anything else for that matter, you can contact us at support@hdexaminer.com. Remember that a free 30-day fully functional trial version of the software is available, so contact us for that if you're interested. This is Jeff Morrow from Sierra Analytics, signing off and saying thanks for watching.